Hello everybody, please subscribe to my channel, like my video, click on the bell notification button and share my video with others. In this video, we're going to use Feynman integral to solve a challenging integration problem. This technique involves creating a new variable into the original equation and then perform some derivative or integration. Then the problem solved, the answer came out like a magic. Define a Feynman function ft which is equals to integral 0 to 1 sin t ln x divided by ln x dx. Label it as equation 1. Notice that this equation is almost the same to the original question, other than change the t becomes square root of 3. In the case that t equals to 0, we have f0 equals to integral 0 to 1 sin 0 dt, which is definitely equals to 0. Label it as equation 2. Apply derivative over dt to both left and right hand side. Left hand side become f prime t, while the x in the right hand side is actually a constant. Therefore, we have f prime t equals to integral 0 to 1 cosine t multiply ln x and then dx. This is not integratable, so therefore we need to do a substitution. Define u equals to negative ln x, which means that x is equals to e power negative u. Then du over dx is equals to negative 1 over e power negative u. Dx equals to negative e power negative u multiply du. We need to find the new limits in u domain. When x equals to 0, u equals to limit x goes to 0 for negative ln x, which is negative multiply negative infinity, which is infinity. When x equals to 1, u equals to negative ln 1, which is equals to 0. Replace u and dx and the new limits into the f prime t, we get the new equation. Cosine is an even function, so therefore cosine negative alpha is actually equals to cosine alpha. Meanwhile, we can eliminate the negative there by swapping the lower limits and upper limits. F prime t becomes integral 0 to infinity e power negative u multiply cosine t multiply u du. Let's implement DI table method for integration by part. We choose cosine t multiply u for derivative and then the e power negative u for integral. The second row is negative and the derivative gives us negative t sin tu, while integral gives us negative e power negative u. Third row is negative. D is negative t squared cosine tu, while the I is e power negative u. Unlike conventional integration by part that require conducting integration by part separately, the DI table method allows us to continue run the integration by part by adding the next row in the DI table. In this case, we have 3 rows, meaning already completed 2 rounds of integration by parts. We can stop after the third row because it is similar to the original f prime t. From here we can get f prime t equals to negative e power negative u multiply cosine tu for u equals to 0 until infinity. Next term is plus e power negative u multiply t multiply sine tu from 0 to infinity minus integral 0 to infinity t power 2 multiply e power negative u multiply cosine tu and then du. Replacing u equals to infinity and then u equals to 0. First term is negative e power negative infinity plus e power 0 multiply cosine 0 plus e power negative infinity minus sine 0. The third term of the f prime t is actually similar to the f prime t itself, so therefore it is negative t squared multiply f prime t. And then rearrange the equation, we have f prime t plus t squared multiply f prime t equals to 0 plus 1 minus 0 plus 0, which is f prime t multiply 1 plus f prime t equals to 1. And then we get f prime t equals to 1 over t squared plus 1. Next, let's do integration for dt to both left hand side and right hand side. We have ft equals to inverse tangent t plus constant c. At the beginning of this video, we already found out that f0 equals to 0. From here, we can find the value of the constant c, which is equal to 0. Now we have ft equals to inverse tangent t, and we label it as equation 3. However, at the beginning of this video, we already defined an equation for ft. Copy this equation and put it together with equation 3. From here, we can see that equation 1 is actually the questions, while equation 3 providing the answer. When t equals to square root of 3, we have the question, which is integral 0 to 1 sine square root of 3 multiply ln x divided by ln x dx equals to inverse tangent square root of 3. The final answer of the question is pi over 3. Please continue support my channel by subscribe, give a like and share with others. Thank you.